Hello and welcome back to the channel, everyone. Today I want to go over a few of the functions and events that we may have skipped in this tutorial series before I go ahead and get this project cleaned up. So I know one thing we skipped was inside of our spawn pad, doing some logic to make sure we're not stuck. And another thing we skipped was inside of our actor component for our wave manager. We did not make this function yet. Okay, so let's go ahead and get started inside of our spawn pad. I'm going to try to make this as quick and simple as possible. We want a custom event in here called run debug check timer. Basically, this is just going to be the timer to see if we are stuck. So we're going to set timer by event. And we're going to promote this handle to the debug timer handle. We're going to run this every 5 seconds. And we're going to have some escalation inside of this, but it's not going to be looping. I guess you could have it looping. It's not a big deal if it is. And here we are going to check debug. And just check debug is fine. What we're going to do is we're going to take occupied. We're going to branch. If it is occupied, then we need to run other stuff. If it is not occupied, we need another custom event called clear debug timer. And clear debug timer is going to need an integer. So this integer is going to be called escalations or something like that. Basically, we're just going to be escalating this 3 times, which honestly doesn't even make any sense. Why don't we just make this 15 seconds and just say if it's stuck on there for 15 seconds? I don't know. I don't know why we don't, but yeah, this is what we're doing. So our clear debug timer needs to take escalations, zero it out, take the debug timer, clear and invalidate it, and we're good. We're done. So we're going to clear the debug timer when we step off the pad. Okay, when we step off the pad, we're clearing the debug timer. When we step on the pad, we are running it. Now, when we are running this debug timer check, basically we need to make sure that we are properly escalating this until we have to kill the enemy, pretty much. So what we're going to do is we're going to set escalations to escalations plus 1. So incrementing escalations would work just fine. So on true, we're going to increment escalations, and if escalations is greater than or equal to 3, so somehow we've gone over 3 or we've finally hit 3, then we are going to run some logic to basically make sure that the enemy kills itself. If not, then we need to run debug check timer, just to loop this again 3 times. We might as well have it looping instead of running this again. I think that'll probably work fine. I don't have any real way to test this, but I guess looping is fine, since we are clearing the timer when we clear. So yeah, if this is false, if this comes up false, clear the debug timer, so clear debug timer. And if this comes up true, greater than 3 times, so this is the 3rd time that we have been stuck in place, we're going to get this other actor, we're going to get the game mode, and for now, we are just going to handle enemy death. Handle enemy death will be fine. In the future, you may want to have like an override in your game mode to kill an enemy and actually destroy the actor without adding score or incrementing the number of enemies destroyed and then restart the timer based on that. But I thought that was a little bit too detailed error handling for our little project at this point. But you know, you may need that in the future. There's a lot of things that we just can't put in every single project because we would be here forever explaining just debug things, right? So yeah, unfortunately, all we're going to do is just handle the enemy death here. So that's if they are stuck for 3 times in a row. If they get unstuck, we will clear this. Or if they just walk off, we will clear this. And yeah, that should be okay. It looks okay to me. All routes lead to clear. I guess after handle enemy death, we also want to clear the debug timer. Because if we don't clear the debug timer, it might still keep ticking. Yeah. Yeah, it might still keep ticking, even though occupied should return to false. Anyway, that should work for a debug timer there. I'm going to leave that for now, and we'll come back here to clean this up in another episode, the next episode probably. So now the other thing we wanted to make inside of the wave manager is going to be this get wait spawn. So we need a custom function here called get weight spawn. Now we're only going to be using this get weight spawn if if use weights is true, right? If use weights is true. So we're going to take this actor. We're actually going to select an actor. I know you love me in my selection boxes. And we're going to select based on the condition of weights. So if weights is false, we're just going to get a random. If weights is true, okay, if weights is true, then we're going to have to run this get weight spawn. And that's going to be pure. And that's going to output an actor. So we're going to search actor, and it needs to be an actor soft class reference. We're just going to call this like out or rolled enemy. That way we know this is the rolled enemy. Now, get weight spawn's also going to need a couple of inputs as well, because I don't want to have to pull out of the spawner details every single time I need it. It's easier for me to just have some input variables to work with. Totally up to you if that's what you want to do or not. But in order to use this, yeah, we will be needing two inputs. They are both going to be in arrays. One's going to be an array of soft actors, and that's going to be enemy classes. And the second is going to be an array of floats called weights. And I'm going to just prefix these with in so we don't get confused about what we are taking in when we are making this function. It seems like that kind of helps everyone understand a little bit better. So yeah, we're just going to plug the enemy classes in, and we're going to plug the weights in, and we're going to use this get weight spawn if we are using weights to get this selected actor. Okay. So now inside of get weight spawn, we have to actually run some honestly not fun logic. I think it's kind of fun, but I'm sure a lot of you are going to think this is very unfun. So the first thing we're going to do is we're going to say is not empty. Both of these arrays, we need to check and see if they are not empty. If we have passed empty arrays in here, then we've kind of flubbed something along the way. There is no weights or there is no enemies, and we need to handle that accordingly. And we're going to handle both in a slightly different way down here. So down here, we're going to take in, so we're going to get in enemy classes to get this input variable. And we're going to see if this is empty. If this is empty, we have a problem, okay? We've failed at life. We need to print a string that we have failed. Because this is not good. I would even toggle a breakpoint here and just return empty. That way we are returning. It's not going to matter because you're going to have a breakpoint here. This should never be happening. This is a critical error, right? Because we passed in the enemy classes directly from our source of truth, which is the spawner details. So if this enemy classes is empty, then we probably haven't set something up somewhere along the lines, or maybe we accidentally clicked the wrong things, or we cleared out our data table or something. And we need to handle this because, yeah, we need to go into our code and actually like do something about this. Now, if that is false, so false is the better option here, we are just going to get a random. Because if it is false, that means we did not have weights. And if we did not have weights, we cannot use a weighed spawning system, right? We just need to return random and get out of here. You know, it's a thing. It happens sometimes. I even forget to click the use weights and just pass the empty array. So that is, yeah, that's something. I guess technically we don't even need use weights because if this array is empty, it's just going to get a random anyway. But I like having that Boolean check on use weights. Totally up to you if you don't want to use that. All right, now let's get into the fun stuff. So we're going to need some local variables here. And these are pretty much all going to be floats. The first one's going to be called cumulative, and the second one's going to be called total, and the third one's going to be called rand. Okay? We're going to take total here, and we're going to be setting total when we loop through this array. So we're going to get in weights. We're going to run a for each loop through in weights, and every time we loop through in weights, we're going to take total plus the array element and set that to total. Because basically what we're doing here is we're just getting a cumulative total of all of the weights in our weights array, right? So a cumulative total of all of the weights in the weights array. And then we are going to check and see if total is equal to 0. And if total is equal to 0, that's kind of a problem. Well, we're going to route this way over here and use it later, because we're going to have another fallback that comes into that. Because we don't want to crash out the game for if we can help it, right? So that's why we make fallbacks, and that's what that is a fallback. Now, if the total is not equal to 0, then we are in a pretty good spot. We need to set our random, and we need to just get random, or I should say random float in range. And you could use a seed here. I don't want to go too deep into seeding, but you could use a seed between 0 and the total. And this is going to be our random. So it's just going to be a random number between 0 and the absolute total of all of the weights in our weights array. Okay, after that, we are going to take our weights again and run it through another for each loop, but this time it's going to be a for each with break. So we're going to take our in weights and say for each with break. And now we're going to be running this cumulative and increasing this cumulative by the array element every time and then setting it. So we're just going to set it here and plug that in. Because now we're basically trying to see if this cumulative value, so whatever we rolled the first time is going to be just whatever we rolled the first time, the second time is going to be the first time plus the second time, so on and so forth. So we need to see if the rand here is less than or equal to, we're going to say less than or equal to, the cumulative value. And if that is true, then we are going to set the index. This is the index that we want to spawn at. So we're going to promote this to a local variable called lindex. Because if you remember when we made our data table, hopefully I told you, you need to map the array of weights to the array of enemy classes, so you know which one is which. And we're going to be using this local index to come around to this break and pull out of it. I'm going to move this route down here a little bit more too. So yeah, now that we have that, we need a default value for lindex to make sure this system didn't fail. Again, we don't want to crash the game for no reason. We're going to take this lindex. We're going to see if that is less than or equal to, I guess equal to would be fine, -1, -1, which is its default value. So if it has never been set up here, then that is kind of a problem. We need to handle it. And how we're going to handle it is right here. And right here, all we're going to do is the same thing we did down here. We're going to take the in-enemy classes, get a random, and return it. Because something has failed and we don't want to crash out the game. We know that we have enemy classes, and we'll just return. Because, again, we don't want to crash the game if we can help it, right? I think I've said that too many times in this video. But yeah, our false branch here is going to need to run one more check. And that check is going to see if the local index is greater than the length of the weights array. So we're going to get these in weights. We're going to get the length and see if the index is greater than that. If the index is greater than that, it's kind of a problem, but not really. What we're going to do if the index is greater than that is we're just going to take this in enemy classes. We're going to get the last index of it, and we're going to get a copy at that last index. So we're just returning whatever the rarest enemy is or the last index. So hopefully that makes sense. It's kind of a thing. You could just use random. Random would be fine. Now off of the false here, we know that this is like not true, so the index should be valid. And we're going to get a copy of that index, and we're just going to return that. Okay? That's all we're going to do there. So hopefully that makes sense. Again, if we are like exceeding or we think we may exceed the last index of the array, we don't want to get it. We want to get the last index and get that and return that. Otherwise, we may get an invalid pull, right? So you may also have issues in here where you're going the wrong way. I know I get confused sometimes. Am I going up or am I going down? This should be down-based. So what do I even mean by down-based? I know this is like the worst part of it, right? Is like, am I going up or am I going down? Down-based, like we have our enemy black and blue here. Our enemy black is 0.45. Our enemy blue is 0.15. So that would be down-based. I'm pretty sure because that's going to add 0.45 to 0.15. And then when we come back around, that is going to add 0.45 if random is less than. So I guess we should be doing it the other way. probably, right? You know, we'll have to come in here and see. What wave is this? This is wave 6. So yeah, we're just gonna start. We're just gonna start at wave, I guess, 6. And inside of the spawn details, let's just make this something egregious, like 0.85 and 0.5. We know that we're spawning mostly blacks and sometimes blues. 0.05. Mostly blacks and sometimes blues. Okay, and yeah, of the 6 enemies spawned, 5 of them were blacks. So let's try one more thing then. Let's try this being 0.05 and this being 0.85. Again, I know I build these things and then I totally forget what they do by the time I ever use them, and I end up having to figure it all out again. But it's a good way to figure things out, right? You just kind of change things around, you play with them. The worst case scenario is you've got to come up with some more numbers, but you're going to be probably modding that data table out anyway, right? I would hope anyway. If you're using this as just a learning example, that's fine, but... Okay, yeah, and now we have mostly blues. So I guess the order doesn't really matter. Well, it looks like it's working to me, so I'm okay with it. Again, I am not a mathematician. This is just kind of a slightly better way, in my opinion, than just getting random every single time. So, yeah, I guess the order doesn't matter, which is cool. It might matter to you, it might not. You're just going to have to fiddle with it. I just thought that was a neato little thing in there that we added on. So yeah, I think I would say that our wave game is largely in an okay state. I'm going to go through and clean everything up in the next episode. That one's going to be a bit long. I'm going to kind of go actor by actor just to make sure everything is done and cleaned up. So if you want to watch that, it's going to be boring, but it'll be here. Thank you for watching. Consider joining our Patreon. For just $3 a month, you'll get instant access to all of the project files and the videos as soon as they come out. Now, on to the next one.